All right, here's part 2 of the Chapter 9 closure. We'll start with part B. That's where we left off of 9-112. What we saw in part A was that we took our original volume, multiplied it by volume scale factor to get our new volume. And we took our original surface area, multiplied it by our area scale factor, and got our new surface area. And we're actually going to do something kind of similar for part B here. And so it's saying Enrique enlarged the solid at the right, so the new volume was 1,500 cubic units. All right, or units cubed, whatever. What was the linear scale factor? So they're telling us we know the original volume, we know the new volume, but we don't know the linear scale factor. And so how I'm going to set this up for part B is similar to how I set up the one here for the volume scale factor, or for the new one right here. Okay, I'm going to take my original volume, I'm going to multiply it by my linear scale factor cubed, and that's going to give me my new volume. We already know the original volume was 12. The linear scale factor we don't know, so we're going to call that x. And we're going to call that x cubed. We're going to say that's the linear scale factor cubed. We don't know what that is. We want to solve for it, so we call it x. And we know the new volume is going to be 1,500. And now we have to solve for x, which is not too bad. But I will need my calculator here. Okay. I have to first divide both sides by 12 to get x cubed by itself. So I divide both sides by 12. And that cancels out here, so I'm left with x cubed equals 1,500 divided by 12, which gives me 125. And now I just need to take the cube root. All right. We've taken the square root before in here, but we haven't taken the cube root very often. But it's something good to know. Say we have, x squared equals 25. We square root both sides to get rid of the x squared. Here we cube root both sides, and the cube root looks like this. It's the square root symbol with a 3 next to it, and we'll cube root both sides. And what that will do is that's cube root's going to cancel with our cube right there. And then we have x equals the cube root of 125. And some calculators have this. If you're using your phone calculator, it may not. I'm using my phone calculator, and I actually do not have a cube root function on it. And so what I'm going to do is I'm just going to Google it, the cube root of 125. And that tells me that the cube root of 125 is 5, which to me makes sense because 5 cubed is 125, so the inverse operation should give me that, which tells me x equals 5, which is my answer for my linear scale factor. Okay? And that is part B and the end of that problem. All right, the last one here is 9-114. It is a longer problem because it is finding the volume and surface area of a octagonal prism, and we'll just get right into it. So the first thing we want to do is we want to find the volume. I'm going to find the volume first and then surface area after of this octagonal prism. Well, what I want to do is I want to do the area of the base. So area, if I'm finding volume really of any kind of prism, I want the area of the base, and I want to multiply that by the height. Okay? Which means why this becomes a long problem is I have to find the area of that octagon on the bottom. Okay? And so what I do is I know that's an octagon. I can't really redraw it, but I know that I always turn my shape into a triangle. This is part A. All right? And I can kind of try to draw it on here. That triangle is coming from down here, that base part right here, which means that this part on the outside is the 0.8. I want to make sure this looks like a 0, not whatever that was. Okay. The next thing I want to do is I want to find what that central angle is. I want to find what the whole central angle is right here. And so I take 360 and I divide it by 8. And I believe that gives me a central angle of 45. The next thing I do is I drop my apothem down and I cut everything in half. And so I'm going to drop the apothem here. That apothem is going to cut that in half. So now I have 0.4 and another 0.4. I have a central angle that got cut in half. It was 45 and now it's 22.5 because it got cut in half. And the height of the triangle we do not know. And that's what we're going to use trigonometry to try to solve here. And so what we're going to do, we're going to take the 22.5 is my angle, 0.4 is opposite, x is adjacent. Opposite adjacent tells me this is a tangent problem. So this is the tangent of 22.5. That equals the opposite divided by the adjacent. The opposite is 0.4. The adjacent is x. And now I can cross multiply and solve here. 1 times 0.4 is 0.4. And the tangent of 22.5 times x equals the tangent of 22.5 times x. To get x by itself, I need to divide both sides by tangent of 22.5. So that those go away. I divide over here by the tangent of 22.5. And I can plug this into a calculator now to tell you the height. 0.4 divided by the tangent of 22.5 gives me 0.97 as a height. Okay, and now I can start finding, I can find the area of this triangle, and then I can multiply that area by 8 to give me the area of the octagon, and then I will have my area of my base, which will be nice. All right, but first, to find the area of this triangle, we need 1/2 base times height, and so I'm going to do 1/2 times the base, and I'm going to use the whole base here. I'm going to use the entire base here, which was 0.8. And I'm going to multiply that by the height, which was 0.97. If I multiply this out, I get 0.5 times 0.8 times 0.97, and that gives me an area of 0.388 meters squared, and that's the area of my triangle. I know that this shape is made up of 8 of those triangles, and so to find the area of my base, to find the area of the base or that octagon, I need to multiply this answer here by 8. And what that gives me, so I have 0.388 multiplied by 8, that gives me 3.104 meters squared. And then the last thing I need to do, following my formula that I started with, which is area of the base multiplied by the height, I just need to multiply this area of the base times the height to get the volume of this octagonal prism. And so I'm going to take the 3.104. I'm going to multiply by my height, which my height of this prism is 2 meters. And I will have my volume. And so volume equals the 3.104 times 2, which is 6.208. And that is meters cubed because it's a volume. Okay? What we need to do is find the surface area of this shape, which means we have to find the area of the top base, the bottom base, and all of these rectangles around it. Okay? So we actually know the area of the top base and the bottom base because we know the area of that rectangle, and we have that area of the rectangle as 3.104. And so for surface area, we are going to have 3.104 from the top base plus 3.104 from the bottom base. And now we just need to figure out, well, what's the surface area of all these rectangles? All right, and I'm going to redraw one of those rectangles for us. Okay, and so we have these rectangles that make up the sides with a height of 2 and a bottom part of 0.8. And I can find the area of that rectangle by just doing base times height. So 0.8 times 2 gives me an area in here of equal to 1.6 meters squared. All right. Well, this is an octagonal prism, which means there's eight of these rectangles, identical rectangles going around the shape. And so I can just take that area of one of them, I can multiply it by 8, which I'm going to do here. So I'll take this, multiply it by 8, and 1.6 times 8 gives me 12.8. And then I can add that to my surface area here. So plus 12.8. And then when I add it all together, I'll have my surface area of this shape. 3.104 plus 3.104 plus 12.8 gives me a surface area of 19.008. And it's a surface area, so that is meters squared. And that is my answer here for surface area. All right. Again, this is the top base, bottom base, and then that is all of the rectangles around the shape. All right. Last part here. It's just saying what is the density of the fish in the tank if there is 208 fish in there. And really all this is we need to take our volume, or sorry, we need to take the number of fish and divide it by our volume here. And so we have our volume being 6.28 meters cubed. And so density is going to be our number of fish in the tank divided by our volume. And so we will have 208 divided by our 6.208. And so my density is equal to, I gotta use my calculator again, 208 divided by 6.208. Well, that's kind of funny that that's in there. And I get a density equal to 33.51. And that would be like fish per meters cubed as my unit there. And there is my density. All right. That is the last problem for the in-class work at least. Make sure you try the homework and ask me questions. I'm happy to even make a video answer or email answer, whatever is easiest or helps you the most, I should say. Get these problems right.